In this problem, we are given the following circuit diagram. It doesn't look too complex, but it kind of is, depending on how you look at it. We are also given this vg1 and vg2, which we're going to plug into our voltages over here, and we need to find the steady state time domain expression for our v0t of our circuit. So when looking at this, we need to find our v0. And our v0 can be found using the node voltage method. So we're going to look at all of the current flowing into this node, set it equal to 0. We are going to do a few things. We're going to convert this inductor, this capacitor, and our vg1 and vg2 into a form where we can combine them. So our vg1 and vg2 is going to be the Phasor form, and then our inductor and capacitor are going to be our xl and our x of c. So first, with our inductor, we have our x of l, and this formula can be found in the notes linked below the like button in the description. It is j times our omega times c. We know that our omega is 5,000, and we know that our c is 0.4 milliamps. So when we plug this into a calculator, we're going to do it as 5,000 times 0.4 times 10 to the negative 3. And this is going to give us a J of 2. We're going to do the same thing for capacitance. However, it's a little bit different formula. We have x of c is equal to negative J over our omega times the capacitance, which is c. Also, I just realized I put a c in here, but this should be times L for inductance for our inductor. Anyways, back to our capacitor. We're going to have negative 1 divided by, and then we get a parentheses here, 5,000 times 50 times 10 to the negative 6, because this is the units for micro, and this is going to give us 4. So we're going to have a negative j times 4. Now to put our equations in Phasor form down here, we're going to have 10 with the angle 53.13, and for our second one, we're going to have 8 with the angle of negative 90 degrees. The reason why it's negative 90 degrees and not 0 is we need to convert the sine to a cosine. And we know from previous homework problems linked below in the description, there's a playlist, that sine is 90 degrees before or ahead of our cosine. That means our cosine is negative 90 degrees behind our sine, and if we convert this to cosine, we just will subtract whatever our angle is of our sine by 90 degrees. And now we can start plugging this into our problem. So first, node voltage method, we are going to have our v0. We know it's going out of our node, so again we have our v0, and this is also going out of our node, so it's simply going to be minus a vg1. We know our vg1 to be 10 with the angle of 53.13 degrees, and this is all happening over our 0.4 millihenry inductor right here. So this is going to be time over J2 that we found. Next, we are going to have our v0 over the 6 ohm resistor. And now for this next one, we can see that the voltage is in opposite directions. So right here, we can see that we have a plus minus. We also have a plus minus here. However, we have a minus plus this way. And since the voltage is going in the opposite direction, we're going to have a minus here. So we will have a plus, and then our v0 minus our negative vg2, which is 8 with the square root of negative 90 degrees, over our negative j times 4, and this is all equal to 0. Now I'm going to move some things around and multiply everything by j, that way we can cancel out the denominators. After we do a little bit of that, we are going to get this equation here. I'm going to combine it a little bit more, say that our v0, and then combine our constants. So we'll have a 2 over 4 minus 1 over 4, that's going to give us 1/4, or 0.25. And then we have a j over 6, which is equivalent to 1 over 6 times j, and that's going to give us a plus 0.167 times j, and this is equal to everything that's on the right. From here, we are going to have to add these values together. Well, if we look in the notes, again linked below the like button, section 9.10, we can see to add these together, we have to put them in the rectangular form. And to put something in the rectangular form, we are going to have to take the value that's outside, so in this case it's 5, times cosine of our angle, which we know to be 53.13, plus j times the sine of our angle, which is 53.13, and then we have this closed off. Once we solve this, we are going to have our number and our imaginary number. We're also going to do this for the 2 negative 90 as well. And then we are going to get these values. So now, since they are in the rectangular form, we can add them together. We are going to get a 3 plus our j times 2. And we can plug this back into our equation. We're going to say that our v0 is equal to this value, 3 plus J2, and then we're going to divide it by this value right here because we want our v0 by itself. Now if we look back in the notes, again section 9.10, we can see that to divide this we need it in a Phasor form. So we're going to have to convert both of these into our Phasor form. In polar form. And to convert from rectangular to polar, we're going to use this formula where we say that our Vm is equal to the square root of our real number. So in this first case for the numerator, we have 3 squared plus the square of the imaginary number. So that's 2 squared, again, all underneath the same root. And then to find our theta, we're going to have theta is equal to the tangent -1 of our imaginary number, which in this case is 2, over our real number, which is 3. And then we're going to do the same thing for our denominator. And now we're going to get these values. From this, we can put our equation back together. We're going to say that our v0 is equal to the top part, which we know to be 3.6, times our 33.69, and this is our degrees, and this is all over our 0.3 with our angle 33.74 degrees. And from here, we are going to take this first part and divide it, and then we are going to take our angles and subtract the bottom from the top. So we're going to punch into our calculator 3.6 divided by 0.3, and this is going to give us the value of 12. For our angle, we're going to have 33.69 minus 33.74, and this is going to give us approximately -0.05. Now we can write this back into our question as 12 and -0.05 degrees. And that is how you would go about solving this problem. If you want more introduction to circuit analysis, there's a playlist linked below in the description, as well as notes for this entire coursework below the like button with the playlist.